So welcome to the second lecture, and in this lesson we are going to talk about the classification of vibration on the basis of direction of motion. So second way of classifying the vibration is on the basis of direction of motion. Direction of motion. So we can classify vibration in three types. First one is longitudinal vibration. Longitudinal vibrations. Second type is transverse vibration. Transverse vibrations. And third type is torsional vibration. Torsional vibrations. So let's study on this case, all these three cases one by one. So just consider, there is a system. So there is a system which consists of a rod and disc. So this is a rod and this is a disc. So this is a rod and this is a disc which can travel up and down here. So now coming to the longitudinal vibrations. So the system consists of, let me write it. The system consists of a rod plus disc here. Now coming to the longitudinal vibrations. So coming to the longitudinal vibrations, so if the disc moves in longitudinal direction, that is up and down here, so in this case up and down, let me write it. If the disc moves in longitudinal direction, that is, we can call it, that is in up direction and down direction, in up and down direction, then the vibration is called longitudinal vibrations. So the longitudinal vibration will always induce the alternate direct tensile and compressive and compressive stresses. So we can visualize this whole thing with the help of this diagram. Let me just hold this whole thing. So we can visualize this whole thing with the help of this diagram here. This is spring, and this is a block here of mass m, and this is the spring constant k. So when this mass moves up, then it results to compressive, like compressive stress, and when this mass moves down, then it results tensile stress. So this is the perfect representation of the longitudinal vibration. Now moving to the second type of classification vibration, that is called transverse vibration. Let me erase this whole thing first. So we can represent transverse vibration with the help of this schematic diagram. This is the axis, and this is the axis of shaft. This is the axis of shaft, and so this is the axis of shaft. So if this disc moves approximately, so if the disc moves, approximately perpendicular to the axis of shaft, which is here, this is the axis of shaft. So if the disc moves perpendicular to the axis of the shaft, then the vibration is called transverse vibration. So in transverse vibration, the rod is subjected to alternate bending stresses. So let me first let you visualize how it looks in case of transverse vibration. So the disc moves like perpendicular to the shaft. So if it is going up, then it will look something like this. And if it's going down, then it will look something like this. So this is the representation of transverse vibration. So in transverse vibration, The rod is subjected to the rod is subjected to alternate bending stresses. Now moving to the next type of vibration, that is called torsional vibration. Let me erase this whole thing. So the third type of vibration is the torsional vibration. Torsional vibration. Now let me give you some clear view here. This is the rod, and this is the disc. So let me project this thing like let me project this thing. So it will look something like this. So the if the disc, this is the disc, if the disc so if the disc rotate about polar axis, this is the polar axis, such that the shaft or rod is twisted or untwisted, then it is known as torsional vibration. So the torsional vibration will result in alternate torsional shear stress. So so this was the last point of this lecture. So in the next lecture, we will classify the vibration on the basis of degree of freedom. So for now, thank you.